So having the characteristic of this bond, 6% coupon, 100 par value, 5 years to maturity. Now we are interested to know what is the bond's Macaulay and modified duration, and what would be the change in the price of bond if interest rate raised by 1.5%. So there are two measures which are related to interest rate risk, and basically they are used to estimate changes in the price of bond, specifically talking about modified duration, if the interest rate changes. So the first one is Macaulay duration. Macaulay duration, as it comes from the formula, is actually the time that a cash flow of bond happens times the coupon, because the coupon is the cash flow of the bond, and it should be discounted by yield to maturity, plus the maturity of the bond, or the year that the par value happens, times the par over 1 plus y, which is yield to maturity in power of time to maturity. And all this should be divided by current bond price. So basically, Macaulay duration is the weighted average of the time to receive the cash flows from a bond. In other words, the number tells us how long does it take that your initial investment in bond be recovered. So to calculate the Macaulay duration, we need to use yield to maturity to discount cash flow. This is very, very important. So we use yield to maturity to discount each cash flow of the bond instead of spot rates. All right. So that one would be equal to the first cash flow over 1 plus yield to maturity. I'm going to fix it by pressing F4 because I don't want this cell moves, in power of 1, because it's going to take 1 year that this cash flow happens. So the present value of the first cash flow is 5.67. And if I drag down, all those formulas would be copied, and the new present values for each cash flow would be calculated. So the sum of them is actually the price of the bond. As you see, there is no difference between these two prices. The first one, we use the spot rates to find out the present value of cash flows. And for the second one, we use just single yield to maturity to find out the present value of the cash flows. And the purpose here is that, okay, for Macaulay duration, we need to use yield to maturity. But for pricing of bonds, either you use spot rate or yield to maturity, the price is the same. So as you see, the price of these two is completely the same, right? So that's the first part for estimating Macaulay duration. Now we need to estimate PV times T. So what is the PV? It's the present value estimated times T is the time that they are happening. 1 year from now for the first one, drag it down, all of them would be calculated. For the last one, which is 75.81, is the present value of the last one times 5 years from now, so 379. And if you sum them up, we have got a number here. So Macaulay duration, I'm going to show it by MAC duration. Would be equal to 452 over 101, the current price of bond. So 4.46. Let me decrease the number of decimals. 4.47. So the unit of Macaulay duration is is year, basically. So what this number tell us, we are going to interpret it in that way. It would take 4.47 years that the initial investment in the bond recovers. Remember, maturity of this bond is 5 years, but it takes for us 4.47 year that the initial investment in the bond, which is 101, be recovered. That's the meaning of Macaulay duration. So how we can interpret it in terms of risk? So as the bonds have got, if the bond have got higher a bond has got higher duration, Macaulay duration, it means that it's take longer that the initial investment be recovered. And as such, that bond is more risky. The second measure for interest rate risk is modified duration. So now we are interested to know what will be the change in the price of bond or underlying security, whatever, if the interest rate changes by, for example, 1%. So modified duration is for this purpose, which is equal to Macaulay duration over 1 plus yield to maturity over n. N is the number of times coupons will be paid per year. So in our case, modified duration, I'm going to show it by MOD, is equal to 4.74 over 1 plus yield to maturity, which is 5.69. The coupon will be paid once per year, so over 1. And we have got 4.22. The unit for modified duration is percentage. So this number tells me if interest rate increases by 1%, the price of bond will decrease by 4.22%. Vice versa, if interest rate decreases by 1%, the price of bond will increase by 4.22%. In our case, the question says, what would be the change in the price of bond if interest rate raises by 1.5%? So if the interest rate goes up by 1.5%, so change in bond price would be 1.5 times 4.22. Again, this should be percentage. So 6.24% is percentage change in the price of bond. Remember, here in our case, interest rate is going to increases. Then the change in the price of bond would be negative. So it means that minus 6.34% is the change in the bond price. And if you want to know what is the new price of the bond, would be 101 times 1 minus 6.34, or can say plus minus, which is actually itself. And this is percentage, so I divided by 100. So the new price of bond would be 94.87. As you see, increasing interest rate decreases the price of the bond and vice versa.